Hi guys, Miss Green here to talk about planetary wind belts, which is on page 14 of your reference table. Um, this chart is a little bit complicated, so this video is to try and break that down a little bit into easier pieces. The first thing we want to look at is this is a model of the Earth, right? We always want to critique our models, so what are some ways that you could critique this model? I think that it's very close to the sun. Probably the sizing, of course. It's also doesn't have a tilt, which is important to notice. It's not rotating or revolving around the sun. So these are all important things to notice. But what is important to know is why, if this is 0 degrees, the equator, why is the equator always so hot? If you answered that the equator is hot because it has the most direct angle of insolation, then you are correct. All of these other locations like 30 degrees, 60 degrees, 90 degrees north even have a much lower angle of insolation, so therefore they don't get as warm as the equator does. Now we know that the equator is very hot, so we know that this is a hot environment. And what do warm or hot things do? You said rise, you are correct. So let's pretend that this is us, we're chilling on the equator, maybe we're on vacation. That air is going to be very hot because, of course, it has the direct angle of insolation from the sun. So as we know warm things do, that air is going to rise up. Now that's not north or south or anything, it's just up in the air. And then, of course, after it rises up, it expands. And then once it expands, it starts to cool and condense, and we start to see these currents. What kind of currents are those? If you said convection, then you are correct. These are convection currents. So at the equator, we notice that that air is rising up. Think about what type of pressure is associated with air that's rising up. If you said low pressure, then you're absolutely correct. Because it's rising up, there's not a lot of air pressure, so therefore it's going to be low pressure. What kind of weather do we associate with low pressure? If you said wet, rainy, lousy weather, then you are absolutely correct. So we know that the equator is going to have an area of low pressure. Now direct your attention to 30 degrees north and 30 degrees south. Because of that convection current, at 30 degrees north, the air is sinking. So what type of pressure are we going to see there? You said high air pressure, you're correct. And because it's high air pressure, what type of weather are we going to get? Very nice. Okay, so I went ahead and filled in the rest of the diagram. It looks a lot like it looks on page 14. Tell me, where do we think that most of Earth's deserts are going to be located? If you said 30 degrees north and 30 degrees south, you're correct. Because we have these areas of high pressure, it's very dry, very low humidity, so most of Earth's deserts are going to be located there. Let's try some regions questions. The climate at 90 degrees north latitude is dry because the air at that location is what? Here you can see the air is sinking based on these arrows, so we know that it is sinking, and cool air sinks. So the air is usually cool and sinking. Try this one. Location C most likely experiences. Because location C is on the equator, and we know that the equator is going to have a lot of precipitation because there's low pressure. So that's going to be low air pressure and high precipitation. So that will be B. Okay, now we need to talk about the planetary wind belts. The planetary wind belts move in two different directions depending whether we're in the northern hemisphere or the southern hemisphere. This is called the Coriolis effect. So the Coriolis effect says that because Earth rotates on its axis, winds are going to deflect in different directions in the northern hemisphere from the southern hemisphere. We'll see this in class, but if you were to rotate a globe counterclockwise and look at it from the northern hemisphere, it looks as though it's rotating counterclockwise. If we flipped that globe without changing the direction that it was turning, it would look as though it was actually turning clockwise. This is why there's a difference in the way that the winds deflect in the northern and the southern hemisphere. So in the northern hemisphere, it's important to know that our winds deflect to the right, and in the southern hemisphere, our winds deflect to the left. Okay, so we know that energy always wants to move from what to what. If you said high energy to low energy, then you're correct. In this case, we're talking about pressure. So here our energy wants to move from high pressure to low pressure, meaning that if we started here, our air wants to move in that direction. But if we started here, our air wants to move in this direction. Now, there is this factor that has to do with Earth's rotation, that because we're going to be in the northern hemisphere, although we want to move from an area of high pressure to low pressure, we have to see our winds deflecting to the right. So instead of just going straight up or straight down, this planetary wind belt is going to move slightly to the right. Now, what's weird about this is that you have to pretend that you are positioning yourself at the X and then going in that direction. So if you were standing at the X, you would be looking down. For you to go right, that's actually going to be this direction. So again, if you are here, now we're in the southern hemisphere, so we know that in the southern hemisphere our winds are deflected to the left. We know we want to go from high to low air pressure, but we're going to be deflecting to the left. These winds are going to be deflected left on their way towards lower pressure. Same thing here. If you're starting at the X and you're moving from a high area pressure to a low area pressure and you're deflecting to the left, then it's going to look like this. Now make sure that you have page 14 of your reference table out for the next couple of questions. This is our first. The curving of these planetary winds is a result of what? We know that the Coriolis effect has to do with the rotation of the Earth on its axis. Number 2, in which planetary wind belt do most storms move towards the northeast? You said from 30 degrees north to 60 degrees north, you are correct. In this case, it's unusual because the question is asking you where the storms are moving towards, or the winds are moving towards. We know generally winds are named for where they come from. Number 3, which wind belt has the greatest effect on the climate of New York State? Well, in order to answer this question, you need to know the latitude of New York State and then figure out where we fall between on our planetary wind belt chart. Because the latitude of New York State is around 40 degrees, 42 degrees north latitude, that falls in between the 30 degrees north and the 60 degrees north latitude range, which means that the prevailing southwesterlies would be affecting our daily climate. Finally, which climactic condition exists when the trade winds converge? When you think about convergent and divergent, these words are now coming back. These vocabulary words are coming back into effect here. Converging, meaning to come together. Very nice. So when the trade winds converge, what type of climate are we getting? What type of pressure? You said warm and wet. You are correct. I would see that this location right here is where our wind belts are converging together. So right at the equator, we have a warm and wet environment. We'll go over this more in class. See you there.